So what if I told you that ancient poetry wasn't just for, prayers and stories? What if hidden inside these beautiful hymns were the keys to really complex math and science? Today, we're not just going to look at history, we're going to decode it. We're going to uncover the secret languages of ancient Indian scholars.
At first glance, this is just a beautiful line of Sanskrit poetry, right? It translates to something like, "In the holy oceans, the knowledge of birth calculation has been accomplished by faith." Yeah, sounds like a devotional hymn, but there's a secret hidden in these very syllables. Something more is going on here.
Because this verse, it isn't really just about faith, it's about numbers. In fact, it's one of the most elegant and frankly complex pieces of data storage ever created. This single line of poetry, well, that's our key to unlocking an entire world of ancient cryptography.
Okay, so you gotta ask, why go to all this trouble? Why would you hide really complex information inside a poem? Well, think about it. In an age before computers, before printing presses, before widespread books, knowledge had to be transmitted orally. So the goal wasn't really secrecy from enemies, but something way more critical: preservation.
Let's think about it this way. Modern cryptography, it's all about securing data on computers, right? But ancient cryptography, that was a genius system for preserving data in the human mind. I'm talking vast amounts of information, astronomical tables, mathematical constants, all of it could be memorized and passed down for generations. Because, let's be honest, a memorable verse is a whole lot harder to forget than a long string of random numbers.
And this wasn't just a one-trick pony. The ancient scholars, they developed this whole sophisticated toolkit of cryptographic methods. We're going to take a look at 3 of the most brilliant ones they came up with.
First up is the rhythmic method. And this is truly mind-bending. You see, in Sanskrit poetry, every single syllable has a specific weight. It's either short, which is called lagu, or it's long, which is called guru. And these ancient scholars had a realization. This natural rhythm, the very beat of the poetry, could be a code. So they just assigned the short lagu syllables the value of 0 and the long guru syllables the value of 1.
And just like that, a simple poetic meter, a pattern of short and long sounds, translates directly into a string of zeros and ones. The poetry itself is the data. This system, which you can find in texts like Pingala Shanda Shastra from over 2,000 years ago, is one of the earliest known precursors to the binary code that, runs our entire digital world today. It's incredible.
So you see, it wasn't just one trick. It was a complete system. You had the rhythmic method we just saw, literally using beats as binary. Then there was the dialectical method, where mathematical rules were cleverly hidden inside riddles and philosophical debates. And finally, the aphoristic method, which used these short, compact verses called sutras to encode huge amounts of data. And that is the method we need to crack our opening puzzle.
So to crack that verse we started with, we need a very specific key, a system known as Katapayadi. Let's dive in and see how this brilliant alphanumeric cipher actually works.
The Katapayadi system is basically a secret decoder ring for the Sanskrit language. It's a really sophisticated alphanumeric cipher where specific consonants are assigned numerical values from 0 to 9. The vowels, they don't have any value. They're just fillers to help form meaningful words that you can actually pronounce and remember.
Okay, so here's how it works. It's basically 3 simple steps. First, you take a word and you just focus on the consonants. You ignore all the vowels. Second, you assign a number from 0 to 9 to each of those consonants using a specific key. And third, and this is the really clever part, you reverse the order of the digits you get. This final twist was actually known as Anakanam Vimato Gati, which pretty much means numbers go from the left.
Let's try it out with a really simple example so you can see it in action. We'll take the common Sanskrit word Rama.
All right, first step, isolate the consonants. That gives us Ra and Ma. Now, in the Katapayadi system, Ra corresponds to the number 2 and Ma corresponds to 5. So reading it left to right, we get the number 25. Simple enough.
And now for that final crucial step, we reverse the digits. So 25 becomes 52. And there you have it, the word Rama, hidden in plain sight, can also represent the number 52. It's simple, it's elegant, and it's incredibly effective. Now you've got the key.
So now let's go back to our mystery. We started with this beautiful verse that seemed to be all about faith and knowledge, but now armed with the Katapayadi system, we can finally unlock its true secret.
Take another look at this verse. It's not just a string of poetic words anymore, is it? It's a highly compressed data file.
Every consonant in there is a digit, just waiting to be read in the correct order.
And when we apply the Katapayadi system, assigning a number to each consonant and then reversing that whole sequence, this is the number that pops out. That is the value of pi, accurate to a stunning 17 decimal places. I mean, just think about that precision for a second. This wasn't some rough approximation. It was a highly accurate mathematical constant, encoded perfectly within a single, memorable line of poetry.
And this was no party trick they just used for pi. This system was used everywhere. Take the word Narayana, for example, which is a name for a deity. Using the Katapayadi rules, its consonants decode to 0, 2, 1, and 5. Reverse that, and what do you get? The number 5120. Sacred names, astronomical data, calendar dates, all of it hidden in plain sight.
Now, this might all seem like a really fascinating piece of ancient history, but the thinking behind it, it's incredibly modern. In fact, these ancient ideas have echoes in the technology we use every single day.
So in modern computer science, we use something called a hashing function. It's basically an algorithm that takes an input of any size, like your password for instance, and it maps it to a fixed size output, a short string of letters and numbers called a hash. It's absolutely fundamental to data security.
Well, the Katapayadi system is, in essence, an ancient hashing function. It takes a variable length input, a word or a verse, and it maps it to a unique numerical output. The underlying principle is exactly the same. It just goes to show that the core concepts of data mapping and compression existed for centuries, long before the first computer was ever even imagined.
It really makes you wonder, doesn't it? If a single line of poetry can hold one of the most important constants in all of mathematics, what other secrets, what other brilliant ideas from the ancient world are still out there, just hidden in plain sight, waiting for us to find the right key?